All right, welcome back. Let's bring this thing home. Here we are with the final of the modules that aren't just tests, which we'll do next. But this time we're talking about proper functions. So you've seen me bop into that command line interface a bunch because it's what's going on. It's what's really happened with the computer. So sometimes your code needs to know if it's being called from the command line or run inside of something. So that means that your Python code needs to be able to figure that out for itself. So it needs to figure out this. You also might want to know what's going on with command line arguments. A lot of times what folks will do with a Python script is they will call it from the operating system. Not always will you first call the interpreter, the Python exe, and then run it in order to get something done. And this is a really popular application for like security scripts, or if you are beta testing some sort of functionality that you're interested in bringing into a project. It's not uncommon to like script up a Python script and that runs from the command line. So this is the thing that happens all the time. On that command line, the operating system or the user invoking the command might want to pass arguments to the program. And we'll see what that looks like. You've seen me do it when I'm in the terminal and I do like an ls-la. That LA is an argument that I am passing to the command line program. And then so finally we'll want you to be able to take all that together and put it into a actual application that you could call from the command line. And I'll show you how to do that in the examples. So there's of course, you can import a module called sysc, and that will tell you if there were arguments passed to it if you use this. And then you've got argument parser, parse arguments, and then you could potentially add an argument and so on and so forth. And get help for things, get meta variables, all of which is very cool. So you've seen me do this. This should be pretty straightforward. The launching the terminal from the library page in Azure. I probably should close all million windows I've got open here. So this is the Azure main page, and you'll notice that it is being told to run on the free compute. It is actually running on free compute. And then there's the terminal button right here. You pop the terminal button and it opens up the terminal. Now, if you've ever used a Linux system or a command line interface, you probably have seen something a little bit like this. That is an application that does that. And if I log into that, and if I type the entire username instead of just part of it, that's what I get for not looking at the keyboard while I type. Try this harder. Finally got it. So this is what the command line looks like. You can do all sorts of fun things with it, like monitor your network usage and make the matrix and all kinds of fun stuff. So that is like the predominant way people interact with the shell. They use a system like this in order to pass commands into the computer, and that's what you're looking at over here. So this is connecting into a Unix system. This is the Unix system that we're running our stuff on. So that's launching the terminal. What shell am I running? We'll take a look at that in a second. We've looked at printing the working directory. We've seen ls. We've seen dir is usually just an alias to ls. So while you can get that. It's really just pointing to this. They're doing the same thing. Dir is, if you're running a Windows system, the command that is used in Windows. You want to get rid of all the muck on the display. That's clear. On a Windows system, it's CLS. Changing directory, we looked at this a little bit. So if you want to know what directory am I in, I'm in home user, blah, blah, blah. And we created that parent dir that all the examples wanted. It's got a bunch of junk in it. If you caught what I just did here, this is maybe one of the most important things you can learn both in programming and in operating a shell. I did cd space, and then usually if you tap the tab key, it will try to complete what you're typing. So here it said I hit the tab key twice, and you can hear that because of my awesome mechanical clicky keyboard. Say I wanted to change into the parent directory. It will complete that command for me just by hitting the tab key, making me look like a way better typer than all of us know that I am at this point. So since there's only 2 files in here, if I type F tab, it will complete that because there was no ambiguity about which file I was talking about. If I go back a directory, list that directory, and if I go to, if I want to copy file 3-4.5, when I type 3, it can't complete it for me because it's still ambiguous which 3 hyphen file I want to type. And if I did 3-4 it's still ambiguous. 4.1 tab. So then it's not ambiguous and it will complete it for me. But hitting that tab key, a lot of IDEs bring this vocabulary of how to interact into them. So oftentimes an IDE will tab complete commands, or sometimes they write arrow complete, but tab complete is really better to do that. So you need to kind of get the hang of working with those directories and working with a command line if you're going to do any serious coding. So if you're not, I'm glad I could introduce this to you. We'll make you struggle a little bit for the next couple of assignments, but you'll be fine. You can walk away and never do it again. If you go into computer science or if you go into systems or network administration, being comfortable in a command line is very important. And I think like a thing you should know how to do. So running a Python file or running Python in the terminal. The Python in the terminal thing is pretty straightforward. It is just Python. And I think I've done this in the past. Python, we've got a bunch of Pythons, and the one that runs when you type Python happens to be linked to Python 2.7.1.2. You quit out by typing quit and making the parentheses, so like it's a function. If you type Python, say we wanted to run 3.6 because we want the newest hotness. Uh-oh, it's not found. Because there's no dot in 3.6 for this one. There you go. Now we're running Python 3.6.6, and we could do Python commands on the terminal. So you could like you could print hello world, or you could do math, or what have you. It's also, you know, when you go back to PyCharmed or your IDE, it'll do that same kind of thing for you. Oh, exit works too. I think I quit. Same deal. Control Z. Yep, Control Z. Oh, actually, I'm in a Unix environment, so Control Z just backgrounded it. More on that if you take a Linux class, I guess. And then that's getting out of Python. So those are all the things for accessing your Microsoft-provided Linux terminal, which I think is great. I think that's pretty cool. Thanks, Microsoft. What I did there, I echoed out the type of shell I'm using. So right now I'm in Bash, which is sort of the default shell for most Linuxes these days. There is a C shell, there's a SH shell. There's a bunch of other shells. They're just the interpreters that provide this lovely interface right here. So like Bash has built-ins like that. It tells you which commands you've run in the past. Those are the ones I've run as I was recording this in the previous lecture. So again, more to love if you decide you're going to move on in the world and get into Unix-like operating systems, which is like basically a requirement for computer science and network administration these days. So running a script directly, importing a script as a module. What is this main function business we're talking about? So here's a lot of the stuff I just worked through. Here they're asking us to make a command line directory that doesn't exist. What? So I guess we'll go and make the directory for them again. And again, here's more commands. Oh, wait, what directory are we in? It wants a command line folder. So we could get the present working directory. Let's just assume it's here. I keep wanting to middle click because, again, humans make mistakes. Paste buttons don't. All right, so now we're in there. We're in the home users blah 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 command line because I had to go make that directory here. And if I do ls, I see that there's that command line and that parent dir I was making it earlier. You're probably going to want me to be back in there later. Empty. All right. Here's our first script that's going to write a file. Ooh, that's a thing. Named mainscript.py that'll have some Python in it. We hope that worked. You can check, though. Another Unix command. Oops, I did it too many times. Since there was only one file in here, when I hit tab again, it created it. Cat concatenates files. Just lists them out. So that's what it put in there. So it created that file called mainscript.py in this directory that has some Python in it, right? So it defines a function, defines this thing called main, which is kind of a big deal these days, and then does this thing here, if name equals main. So now we can run this script directly. So this is going to launch that same command line interpreter, bash, that we've been using in the terminal, and then it's going to do a thing. And that thing is it's going to run Python mainscript.py. What's that do? Oh, it's running the main function. Running the main function. Def main. If name equals blah, main. So for some reason there's this, remember we said double underscores are probably private variables. There's this thing there magically called main. And another thing you can do, I mean, you don't have to do that from the old notebook. If you just run that script, that's what it does. So now here we're going to make a second file. It's going to teach me to be careful with what keys I press. Now we're writing a thing called secondaryscript.py. What's going on here? All right, so my Jupyter notebook has created this guy right here, secondaryscript.py. Let's see what's in there. Oh, cool. So it imports the main script, and then it calls func from the main script, and then they didn't put a new line at the end of their code, which kind of a pet peeve of mine. We'll let them slide for right now. But it's a nice thing to do. Nice thing to print a I'm over it. But it's considered polite. Anyway, so if we bash that secondary py, now it's running func. So mainscript.func. Oh, so it imported the main script and it's running mainscript.func, the function that's in there. So it's running this thing up here, running func. Cool. So now we can import somebody else's code into our code and run things through it. Run their code. So again, lazy like a fox. Now we don't have to write things. We can just borrow somebody else's code. Share, man. That's what it's all about. Sharing. So in a command line, we've seen ls, right? Now there's all this stuff in there. ls accepts options, so like ls-l, ls-la. You get a little more info with each of them. A just shows you the dot and the dot dots. Nice to remember they're there, especially if you're worried about security. So those are options, and the format for a Unix-based, even a Windows-based command is that it takes command arguments options. So to change the working directory, cd, change the list of directory contents, ls, and then there's some argument or some arguments that you can add to that. And then ls accepts directories or paths as options. And you saw me do a little bit of this earlier in the course as well. So I would do a quick ls to figure out which directory we were in. It was the same thing as when we called the system function to figure out what the present working directory was. So here we're listing parent dir and hey, it exists, ... forward parent dir. Pretty cool. So let's make a new file. We've used the same trick we've been using so far to create a file. And what that does is it imports sys, creates this new thing, this new integer that is the length of this sysv.args, argv. It's going to loop through it. What happens if we just print it? Oops. What happens if we just run it? Oh, there it goes. So here it's got braces around it. So what does that mean it is? Some sort of listicle thing. So 5 arguments went in. 1, 2, 3, 4, 5. So when we ran command line.py, 1, 2, 3, 4. 4 arguments and options. What were the first one? Oh, so technically the 0th argument is the name of the script. I see what's going on here. And so again, if we went back over to our terminal, did it put it in this directory? I think it put it in that directory. Yep. Oh, no arguments were passed except for the script itself. So you do. And this will actually be right because it starts counting at 0 with the script. Oh no. Did it want 1 or 2 hyphens? Oh no, arguments then options. Wait. I liked only 1. Our script isn't great. Oh, what am I doing wrong here? I was just catting it out, and it was accepting those things as arguments. So let's try this a little bit harder now. Wait, where did I put this thing? Oh, it's probably in command line. Oh, there it is. So if you do it right, it will go through and tell you that 5 options and arguments were passed. It read it all into this thing here. There's our output. And then we iterate through those to get the individual arguments. So just basically doing on the command line what we're doing here inside of the Jupyter Notebook, right? Oh, you want some random numbers? Sure. So here we've imported this argparse and randint. And then we create a parser argument, this argparse thing. We create a command line arguments, which is parser.parseargs, and then a random int. And we run it. It appears to be giving us something that appear to be slightly not random numbers. Pretty good. Uh-oh. Here, we gave it an unrecognized argument. It didn't know what to do with that. here. Oh, dash H. Asked for help. That's a very useful thing to say. Although, you might want, if it accepts dash I, to do something useful. But the fact that it is doing all of that just by having that argument parser imported is pretty sweet, right? We didn't have to write code to do that. It just did it by magic. So here we've gone back through. We've got arg parse imported. We're going to randomize again. Now we've got parser equal to this. Parser add argument. Oh, look, it's conveniently making nicely formatted error messages for us. So that if we run it, it says the following arguments are required. Count. What is count? Count random integers to be generated. Oh, help. Show this. Well, that's great. So just based on adding this one parser.add comment, it has made our script very, very professional looking. Very nice. And now if we run it the right way, we get 4 random numbers. But that's really not the tricky part. The tricky part was this whole help file thing, just by adding that dash H. Here, let's upgrade that script again. So now we've made it a little trickier. So we've got this argument about the count, and this argument about the range, and the integer range from which will come. We pull those in. Now we run a program that just basically loops through stuff. We're pretty familiar with how that works right now. So that's sweet. That's sweet. That's sweet. That's sweet. You could make these numbers a lot bigger. That's sweet. But here's the interesting part. Right, so that's how it's supposed to work. But when you run it without doing anything, it says the following arguments are required, and then asks you to go back through and look at the help file. Oh, look. And now it's got a really nicely formatted, professional looking help file. And this is the sort of thing you expect from good professional code. If you are, running a new download off of the interwebs on your Unix box, you want it to tell you how it is you're supposed to be using it, which is nice. And with pulling in a couple of little pieces of help from our friends, the guys who wrote the argparse and argument parser functions, we're in business. Super nice. There was that tuple metavar there. So it gives us a little more functionality. Metavar takes upper or lower and basically creates a bool from them. Upper, lower range, integer range from blah, 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 which will be chosen. Add argument here if we wanted to, say, make things verbose, which is cool. Nice to get back, so -v will give us more feedback and tell us what it's up to. Take that out. You get less verbose, which is a thing, again, that is frequently used inside of professional-ish code that you will download and run. Much nicer. And then you get this verbose mode is a thing. And it's like one of those things you sort of just expect to be there. Oops, I spelled it verbose. So when you're running this sort of thing, if you pull down a new piece of code, you'll find that that looks a whole lot like the other code you will find on the interwebs. Oopsies. Now my shell has gone really slow. Too far. Too far. Okay. Really advanced bash scripts will also let you command tab complete things, but I don't think we're going to expect that out of a Python script. And then there's all this stuff about action that can be used to make things work better. Here's randpy with a new verbose and the action stuff installed. Pretty impressive. And then go through and make a command that will run through and figure out the days of the week. So that is scripting. And again, just a little bit, just a taste of how that works. You can find more about our friend argparse. Just tried to write on my screen with a mechanical pencil. That would be bad. There, in the Python documentation, sysv, argsv, argparse help you handle all that argument and parameter stuff. Because lots of these scripts run as command line scripts that you run in a Linux box, or that get incorporated into a... All right, so those are script environment and command line arguments. Now let's talk about the scope of a variable. So variables are only in effect in certain areas in the memory of the program, sections of the program. Sometimes those are called local variables. It will be important to be able to read and modify those, but more importantly, it will be important to figure out what the scope of variables are. Because if you try and access a variable that lives inside some function somewhere, you may not have access to it. Or it may be created in a function and you think it's going to be there later, but then when the function's done running, it disappears. Now you're in trouble. That would be a great place for like a global variable. So you can play around with how to read and modify those, and we'll look at def and global. So local variables live within a specific scope, but it means that those names can be reused all over the place in a different scope. So like every time somebody does like for I, do they have to worry that somebody has used I somewhere else in the code? That's one of the nice things about scoping your variables. So it's a pretty straightforward concept. Here we have, and this is a good one to feed to the Python visualizer. So here's pretty straightforward, right? We're computing the area of a square. Everybody loves figuring out area of squares, right? So here's a function square. It takes the side, and notice here we are inside the function, and here's this variable called side2. Multiplies that out. Here's a variable called area inside of square area. Returns a value. Bloop. Where'd those variables go? Bloop. What? I just had area back here. But it was inside the scope of the square area function. I see what they're doing there. Oops, I should close that. It's just going to confuse me. So here's another one. What's going on here? Oh, another error. Goodness. I wish somebody would have handled all these errors. Raised some exceptions or something. So here we're computing the area of a square. We're going to define this function here. We're going to define this function here. Okay, that's great. Okay, that's great. So notice that when you're interpreting these functions again, we just kind of like, we know that they're there, and if you happen to call the function, we'll jump back there. So we're going to set s equal to 2, square area is equal to s. Here we've created this function called square area. It's got its own little scope there. The blue highlight does its math, returns something called area. That's great. Now we run cube volume s. So it's going to take volume equals area times... Area is not defined within the scope of cube volume because it was defined back here inside the scope of square area. And as time went on, square area finished up and it passed back its returned value. It does not still exist. So like this concept can be confusing, and it like if you lose track of it while you're coding away, it can get you into trouble. And then like you can go through and use that same variable. Thanks for your help, Python 2. So boom, boom, we run through square area 2. Now here we've fired up our new function called square area, and it does its thing. It's got a variable named area, which is starting to be one of those words that the longer I look at it, the more it looks like it's misspelled. But it's got a variable named area. This is the thing we're trying to illustrate here. It returns the value. Now we fire up this rectangle area thing. It takes two arguments because you can do a length and a width on a rectangle because geometry. And notice that again, it's got a variable named area. It returned none though. What did we screw up there? Anyway, that's not what we're looking at right now. Oh, because it doesn't really return a value, it just prints out of it. Okay. I see what they did. Normally you might want to return that value instead of just printing it out yourself, but yeah, whatever. So there you go. So there is an area in this function, and this is its scope. So right there is the only place that scope exists. And we've got the same variable name up here in the square area function here. We've got one in the rectangle area function there, but they have different scopes. And down here is what we call the global scope. So far, so good. Have at the task 1 here. Pause me and go through those real quick. Figure out how to convert some currency. So that's all well and good. Those are local variables. You can have isolated local variables. So say you've got a function with a sub-function in it. Those get destroyed when that sub-function ends, and they return function to the original scope. So that's fun, right? So let's look at examples of that. That'll make things easier. And again, I think this will make example much easier if we visualize the code. I'm going to send this guy a buck. I think these are useful. So here we've got a bunch of functions, right? We've got this def square area, we've got this def rectangle business, and now we've got this def area diff. Oh, I see that. We're going to compute the difference. So code runs. We up here in the global frames, we're aware that there are some functions up here that we'll worry about when we get to them. Skip down for that differential area. And now down here, with one mighty line of code, we call this area difference equal boom. So area difference calls this function, which calls a sub function, which does some math and it returns a value instead of just printing things out. Named area, that's cool though. Area 2 is some other thing, which is the rectangle value. Again, there's a variable name in there called area. We're reusing the same variable all over the place, which if you're writing your own code, maybe that gets a little confusing. And then does the difference where it subtracts A from B, returns a value, prints it out. But that's the important part. So like you can have functions call functions using the same variable name, but once they're in that new sub function, doesn't matter. Even though we see right here that area diff has a bunch of stuff in it. Named area even. It still works just swell. Whew. So there you go. That's local scope and isolated local scopes. What about global scopes? So these are global within a module, and they live outside of functions, and they can be read from either global or local scopes, although careful with that. So examples again, you know, because computer scientists are oftentimes frustrated mathematicians, let's calculate pi, shall we? So here we've got this global variable of 3.14, which isn't pi, but good enough for government work. Skip that. Now we've got this circle A is equal to a circle area. That's great. Radius is equal to 4. Do some computation. Return a value. Wonderful. We've declared a global variable that this guy gets to right here. So cool, right? Nice to be able to do that. You can do that with strings. It's a Python class, so Monty Python jokes. Normally you might be counting spam in these sorts of things, where we go through and count the number of vowels in Monty Python, which is always fun. There you go. Free Monty Python reference. But you get the idea, right? So we've got a global variable, which is the vowels. We've got down here in the global scope. Figure out the number of vowels in this variable, and then call this count vowels function. You can change a variable, a global variable, from a local scope. We should watch it do it. I'm hitting Control-Enter on this now because I've been playing with Jupyter Notebooks all semester. So here's a global variable. We've got a value in it, pi. We've got a new one, pi equals pi. Circle area, oh, we go up here. It says, you know what? I got a better value for pi. And notice that it changed the global pi. All right, we said, hey, use this global variable here. Dunk. Returns it, and now when we print it out, a more accurate circle area is that. And we've updated pi to another couple of digits of precision. But more importantly for this course, when we did this, we went through and from a local scope, by declaring the global pi value, said, hey, grab this variable right here from global land and let me play with it there. And that's sort of the important takeaway from that one. You can get to a global variable from the local space. And we can do it again here with strings. Sure, it looks like that. What if you want to assign a global variable in a local scope without using that global thing? Here we've got pi. We've created this circle of a radius, made a more accurate pi, set it out there. Wait, what? Oh. Here we go again with string variables. Not so much. You can't change them from here. So if pi is equal to 3.1 and then later on you set pi to 0, not so much. Same with strings. So good. So have some fun with global variables and flip some stuff around. Oops. I'll remember where I put things on my desktops at some point, I'm sure. And that's variable scope. So the rest of this stuff, we're going to talk about making better code by documenting. And like, I feel like this should have been the first thing that we talked about. Maybe I'll flip the order around. But I think you've seen me do like ... so that I can have strings inside of there and not worry about escaping stuff. This is a special way to make multi-line or one-line doc strings and then how they can be accessed. So the idea here is that you will document your code. Boy, is it nice when people do that. There is this thing built in called docstrings in Python that makes it easier to document your code and then makes it easier to use other systems to document your code. So for simple functions, you do a one-liner. Multiple docstrings are like those those help files that we saw in the command line code, but you can even call them with a help function, which we'll look at in a bit. So those conventions that we follow for creating doc strings, triple quotes to start them, ideally have a summary with the imperial voice and ending with a period, and end them with a blank line, which is also good practice when writing scripts that run on the command line, but okay. And then there's a PEP that talks about this, a Python improvement. Which explains what you should do. PEPs are great. And an important thing to follow. It is as Guido would want it to be. So those are the doc strings. We should take a quick peek at those over on the other window. So here's an example. Single line. If you print the underscore underscore doc underscore underscore, those are the conventions for keeping things private. That's a specialized one. When you do the dot blah blah blah, you get that. Here's a longer one with the whole triple quote convention and multiple lines. So triple quote, bunch of lines, triple quote. Tells you what it does, tells you the arguments and what it returns. Notice that you get the same thing if you call the help function to access doc strings. So it can be accessed either by printing the underscore underscore doc, which again, private function, you're not supposed to play with it or change it, or asking for help. So pretty straightforward. It's the right thing to do. It'll help your sanity and the sanity of whoever has to look at your code next. That feeds into PyDoc. And PyDoc is a way to generate text or HTML documentation. So in the Python programming language, we knew that you wanted to do a lot of documentation. So we made it easy to do that. And we made this functionality here that will create documentation for you using doc strings that we're already going to use because we're going to do great documentation, and then spit out HTML or text documentation. And we have examples of just how that works over here. So here's that Celsius stuff, right? We've created a document. Now we're using PyDoc from the command line to create that. So if you wanted to, what this is almost doing, does that still work? It still works. Where did we put it? C2F. Oops. Another convention that can be used inside of Unix is that tilde I just grabbed is the home directory of the user. It's another variable. There it is. Of course, it's in exactly the directory I'm sitting in. C2FPy. So as I was saying, the reason we do this, PyDoc's business, and and there's several of them installed on the system. So it creates documentation, right? If we were to create a file called help.txt, and we wouldn't make it all caps, and we'd be much more tidy about it. We would now have, that's all we have to do to take all that documentation we wrote into our code and present it to the user. So we've taken that C2FPy and popped it right out of there. And that's what this thing is doing by printing that out. And here we've got a program that does some kilograms, and it says, oh, look at all that. So pretty easy to do. So have at it. Make some of your own documentation. Really, we probably should have put that first, because you should document the bejeepers out of all of your code and make sure that whatever poor soul comes after you can do all that. So there's a lab to practice, and we'll see you guys online.